Hello, hello. Yeah, so we'll start in few minutes. Good evening, everyone. We'll start in few minutes. Today's topic of discussions are these four topics mainly. So will be so you can say only three topics. So one is solution of higher order homogeneous linear equations and non-homogeneous linear equation, of course higher order, and then Cauchy-Euler equation, which is like also will be non-homogeneous linear, or it can be also homogeneous, it can be non-homogeneous, but yeah, it's one special kind of differential equations. Okay, so mainly nth order differential equation of nth order. So how it looks like? Okay, so yn, so y is a unknown variable, and the n means n times you derivative, take derivative of y with respect to unknown variable, sorry, with respect to unknown variable x, and you this is, so this is how it looks like. One nth degree, and sorry, nth order linear differential equation. Order will be n and degree will be 1 always. So plus p naught x y is equal to fx. This is a general linear differential equation of order n. What is the meaning of yn? I mean, in a very easy scenario, you can think like this. I mean, not think like it is. It is like it is this only. Okay. Okay. So when we will call it linear, or sorry, it is always this is linear. Mainly, this is linear differential equation. Okay, this is linear differential equation of nth order. Okay, so there will be two cases. Case one, if fx is equal to 0. What is the meaning of this? For all x, fx is equal to 0, then it is called homogeneous equation. Okay. Case 2, there can be two cases. If fx is not equal to 0, I mean at least one point is there where f has non-zero value, then it is called non-homogeneous equation. I mean the linear nth order equation you can uh, classify in other two types. One, if the right hand side function is non-zero and zero, depending on the right hand side function whether right hand side is there or not. If it's there, I mean if fx is not equal to 0, then you say it is non-homogeneous equation, otherwise it is a homogeneous equation. So that's why these two are there. So we will be talking about mainly this equation. So when fx is 0 and fx is not equal to 0 for both cases, but the thing we will restrict ourselves in linear case. And then we'll talk about Cauchy-Euler equation, that while doing the example, the problem, I will be discussing that. Okay. So let's now start with how to find the solution. So to find a solution of a, let's say you want to find a solution of, let's say this type of like y2 plus y1 plus y is equal to x. So in order to find the solution for this system, as all of you know, I hope all of you went through the lectures, the lecture videos. So that will be solution for this system will be general solution. Solution will be the solution for the homogeneous one. So you make this quantity is equal to 0 and then you take a solution plus the one particular solution. So I hope all of you understand what is the meaning of this. So when we call the solution for this system, it has to be like it we can write in terms of two other solution, addition to other solution. One is solution for the homogeneous one, and another one is particular solution. Okay. So let's discuss now what is solution for the, how you derive the solution for homogeneous equation. Okay. So for to derive the solution for the homogeneous equation, what we do, let's say for this one you want to do. So what we do, you have y2 means you have derivative of y twice you have, and this is once, and then y is equal to 0. This is the corresponding homogeneous equation. Then what we do, the procedure we follow will be m square, put m square plus m plus 1 is equal to 0. Okay. This comes from like y is equal to a e to the power mx, this type of assuming this type of solution exists, we can write this. Okay. Then you find what are the values of m. Okay. So we solve this. So in this case, what will be m? M will be minus 1 plus minus square root of 1 minus 4 over 2, right? So minus 1 over 2 plus minus iota square root 3 over 2, right? So you see it's a imaginary root you got. So what we will do in the case of imaginary root, we'll have this the solution will be solution for this system for one, solution for one. How you can write the solution for this one? So this one solution for this one will be y, which is the solution for the homogeneous equation, which is yc we sometimes call, that it will be e to the power minus half x time cos of root 3 by 2x plus iota sine root 3 by 2x. Right? If you see, I gave one example here, right? So if it was, if it is like, let's say if it is like y, let's say y2, or like I started y2 minus 2y 1 plus, let's say minus 3 plus 2y is equal to 0. In some example you get like this. So what will be the solution for this? Solution for this will be, so first of all you have to find the auxiliary equation, mainly we call it as auxiliary equation. That will be m square minus 3m. The coefficient will come as it is, that's 2 will be coming 2. The previous one coefficient was 1, so I just wrote 1, so here it will be 2, sorry, not m, this 2 is equal to 0. That's like m square minus, we want to find the roots here, so here it will be 2m minus m plus 2 is equal to 0, and that implies m times m minus 2, right, minus 1. If you take common, then it will be m minus 2 equal to 0. That implies m minus 2 times m minus 1 is equal to 0. So you can have real roots also. Here you see these real roots are 1 and 2. Okay, so in this case what will be the solution? Yc, the solution will be c1, an arbitrary constant. Here also arbitrary constant I did not put, so but that you can put as a cos x plus b sin this x. So here it will c1 e to the power x plus c2 e to the power 2x. So if roots were like 1 and 1, so it will be c1 e to the power x plus, you cannot write just c2, so it has to be x times c2 e to the power x. Okay, so that's how you have to proceed, and this will be, in that case it is like this. So I think all of the possible way I have said. So if in the case m is 1 1 1, it can be third order differential equation, linear differential equation. In that case it will be c1 e to the power x plus c2x e to the power x plus c3x squared e to the power x, right? So for 3, so it will be like, if it is m is nth order differential equation and its repeated root of order m, then x to the power m minus 1 will be coming into the picture. Okay, so for the, so this is just to find the solution for homogeneous equation. And once you know homogeneous solution for the homogeneous equation, you need to find out the what is how to find out the particular solution. So first let's do couple of examples here before going to particular solution. So yeah, So you will see if the differential equation is of order 2, if of is of order n, the arbitrary constants in the solution will be of the same number. The number will be n. Okay, so that is one thing I wanted to say. Yeah, so let's have a differential equation, homogeneous differential equation. So let's say you have d cube minus 7d square plus 25d minus 175 of y is equal to 0. I mean, what is d? D is ddx. Okay. So in that case, what will be the auxiliary equation? Auxiliary equation will be y to the power, I mean, m cube minus 7m square plus 25m minus 175 is equal to 0. And this is, let's say it is given to you what are the root, then how to find the solution. Okay, that's what I am making here. So what I am writing this m, let's say you know m minus 7 times m minus 5 m plus 5 sorry m minus 5i times m plus 5i. Okay, 0. So in this case, then what will be the solution? Solution will be yx. The solution for the homogeneous equation will be yx is equal to c1 e to the power 7x plus c2 to the power, sorry, c2 cos 5x plus c3 sin 5x. That will be the solution, because one root is for m minus 7, the real root, that will be exponential, and other two are imaginary roots, conjugate root, so that will give you cos x and 7x, cos x and sin x. That's what I said already here, right? This is yeah, here already you have seen. So here you see the solutions are the imaginary roots are 5 plus minus 5i, means you have 0 plus minus 5i. So that's why you don't have any e to the power 0. So e to the power 0x is 1. So that's why you don't have here any exponents. Okay. Yeah. So now we will move to particular solution. Okay. So mainly we want to solve non-homogeneous differential equations. So then you need to know what is particular integral or particular solution. So let's say you have this type of differential equation, d cube minus 5d square plus 7d minus 3 times y is equal to 3x. I mean, the solution for the homogeneous equation, it will be very easy for you once you know, once you go through what I have said and the videos. But how you evaluate the particular integral or particular solution, one is the thing. So the solution for this differential equation will be the addition of those two. Okay, so if you have the in the right hand side e to the power ax, let's say, then this differential equation will have the solution for the particular integral will be, and you can write this as fd, this whole thing, right? You can write this one as only. So then what you can write this e to the power ax over fd, or I mean, let me write it in another way, e to the power 1 over fd times e to the power ax. This one will be, general rule is there, it is said it will be fa, it will be, I mean d will be replaced by a, d will be replaced by a, sorry, oops. Sorry, some issue with the pencil. I will just check it. Okay, so let's move. So there is there are some issue with Apple Pencil here. So some I will take few minutes. Okay, please wait. Okay, so I think it's working now. Gosh. Okay, so here what we have, this it will be e to the power ax over 1 over fa times e to the power x if fa is not equal to 0, and if it is fa is coming out to be equal to 0, then the solution will be x to the power r over fra times e to the power ax else, and here r is like fd. If fd you can write as d minus a times to the power r times some fd, some other fd, some g of d, where g of d is g of a is not equal to 0. Okay, so this is one example. This is for general. Okay, in our case, so let's say you want to solve this one. So let's say this is our question. This is a question how to solve it. So first of all, you have to find out the complementary solution or the solution for the homogeneous one. Okay, okay. So first, for the complementary equation of the solution for the homogeneous equation, what we do to find out the auxiliary equation, the 7 minus 3 that is equal to 0, and so how do you find out the roots of this equation, right? roots are, I have to find out a root, maybe m equal to 1, it is satisfies it. So that thing will be m square times m minus 1 minus 4 m times m minus 1 plus 3 times m minus 1. That will give me everything. So that means m minus 1 times m square minus 4m. So that I can write 3m minus m plus 3 that equal to 0. That implies m minus 1 times again you will get m minus 1 times m minus 3. So so what are the roots? 1, 1 and 3. So you see 1 you have twice. So the solution for the homogeneous one, so we denote by yc, that yc of x, that will be c1 for x plus c2x to the power x plus c3 x. That is one. So we haven't yet got the solution for the question, the answer for the question. Okay. So now we have to find out the particular integral. So particular pi you have to find out. So pi, so that will be yp, or pi and yp of x, that is 1 over fd. So means fd means in this case 1 over dq minus 5d square plus 7d minus 3 times e to the power 3x. Right. So as I said here, how do you solve now? 1 over fd times e to the power x. So if you put y is equal to 3 value, d is equal to 3 means if you put 3 here, you will see this will vanish because 3 is one of the root. So what we do is here, so we take d minus 1. So this you can write always d minus 1 whole square times d minus 3, because that's the that's how you got the auxiliary equation also you got like that. So times e to the power 3x. So what I said here, that this one then you can write as, this is let's say fd, then what will be f, you have 3 you have twice, right? So in this case what will be the solution? So 3 you have 1, so it will be f prime d. What will be f prime d? It will be 3d square minus 10d plus 7, right? Okay, so f prime d, you put in the f prime d, yes, so it will be x over 3d square minus 10d plus 7. So again this is coming 0, right? So you should not put 3 here. So times it equals 3x. If it was non-zero at 3, then you would have right just the value. But here it is not like this. Sorry. So you can write, right? So what will be this at 3, right? So it will be at 3. So now it is x time e to the power x time 1 over 3d square minus 10d plus 7 times e to the power 3x. Right? So that you can write as e to the power 3x over, this is now your fd. Now your form will be in the first case, if fa is not equal to 0. What is fa here? 3 times 3 square minus 10 times 3 plus 7. Okay, so 27 plus 7 minus 30, so it's equal to 4. So it will be x times e to the power 3x over 4. So x e to the power 3x over 4. So your particular integral is y x is equal to x e to the power 3x over 4, and you had this yc, which is complementary solution, and the solution for the homogeneous equation. That's how the answer will be. Answer with the solution for this answer will be yx is equal to y cx plus ypx is equal to c1 e to the power x plus x c2 x e to the power x plus c3 e to the power 3x plus x e to the power 3x over 4. So that's how I started for a non-homogeneous non-homogeneous linear differential equation. You can write the solution as the solution for the homogeneous equation plus solution for the particular equation. Okay. Hello. Hello. Okay. So that's now you got into how to do it. So, but now you have done it for e to the power 3x. So, how you do for some other function? So, before that, let's do another question where the right hand side is e to the power 3x. So, while changing e to the power 3x e to the power ax to some other function, the rule will change. So, that's why I am doing some questions from the which involve the right hand side as e to the power 3x. Sorry, e to the power kx. Let's say you have to find out the particular integral. Now, complementary the solution for the homogeneous equation I have now. For this question, you don't need to find out. Okay? So let's say you have to find out this step. So this is the particular integral. So plus or minus x. So this is mainly that implies this is like fd times y, or fd upon y will be equal to 4x plus e to the power minus x. That implies the particular integral which you need to find, that is nothing but e to the power 4x over fd plus e to the power minus x over fd. So this you can write. So let's say one by one. Okay, e to the power 4x over fd. You can write as, you can evaluate this as e to the 4x over f4 if f4 is not equal to 0. But let's check for what is f4. So f4 mainly, if you put f4 here, so 4 cube minus 9 times 4 square plus 24 times 4 minus 16, that will be 0. So you cannot write it over 4x over fd as f4. Okay. But what about it over minus x over fd? So can you write this as e to the minus x over f of minus 1? If it is not equal to 0, you can write it. So let's see what is f of minus 1, which is minus 1 cube plus minus 1 cube minus 9 times minus 1 square plus 24 times minus 1 minus 16. That will be minus 1 minus 9 minus 24 minus 16. So it will be minus 10 minus 40. So it will be minus 50. Right? So e to the power minus x over fd is equal to minus x. You can write as f minus 1, because in this case fd is dq minus 90 square plus 24d minus 16. That will be e to the power minus x over minus 50. Minus e to the power minus x over 50. Right? That's what you get it from e to the power minus x over fd. But e to the power 4x over fd you cannot do that easily. So you have to mainly factorize this dq minus 90 square, dq minus 5d square. So you have what is fd here. So to find out this, we have to what is fd. Fd is dq minus 90 square plus 24d minus 16. as you have seen, why you cannot write this fd is equal to e to the power 4x over f4, because f4 is a root. So always you can factorize like d minus 4 minus 90 times, sorry not 90, 5d times d minus 4 plus 4 times d minus 4. That will give you d minus 4 times d square minus 5d plus 4. So you will see then it will be d minus 4 square times d minus 1. So you have d minus, so e to the power 4x over d minus 1 times d minus 4 square. So how you can write this one? You can write as, because you have d minus 4, in the d minus 4 you have power 2. So what you have to write is x to the power 2 over f prime 2, sorry not double prime, which is evaluated at 4 times e to the power 4x. Okay. So what is f double prime? So f double prime d will be derivative of dt of 3d square, one derivative minus 18d plus 24. That implies 6d minus 18, right? So that will be x square e to the power 4x over 6d. D is now value is 4 minus 18. So 24 minus 18 is 6. So it will be x square e to the power 4x over 6. So that will be the solution, right? The solution means particular, not solution, particular integral. Solution for this question. This question, if it is asking the find out the particular integral, as it's asked in the assignment of your assignment, 12th assignment, 4th question, question 4. This is question 4. As I don't know, it can be different for you, but one of the question I can see in your assignment, it says that find out the particular integral for this equation, for this linear homogeneous, non-homogeneous equation. So you just have to find out like this, and you get the solution. Yeah, so solution will be x square e to the power 4x over 6 minus 1 over 50 e to the power minus 6. So we started like that. So use 2 as addition of 2 function. So now let's say we want to find out the particular integral when RHS is different. So let's say RHS you have some different function like sin x or cos x. If you have RHS right hand side function, which is like which makes the homogeneous differential equation as non-homogeneous, that is RHS right hand side function, which is non-homogeneous. Let's say RHS is cos ax or sin ax. Then the particular integral you can, it will be like cos ax or sin ax also, no problem. And d, that you can write as 1 over f minus a square. So don't make mistake by writing minus a whole square, because that does not make sense. That will be a square root. Here it is minus of s, not minus a whole square, minus of a square times cos ax of, or if it is sin ax also, or it is sin x also. If f of minus a square is not equal to 0, only then it will. what if f of s square is not equal to 0, becomes equal to 0? Okay. So if f of minus s square is equal to 0, then you will have a factor like d square plus a square, right? So you will have a factor like d square plus a square. So in that case, the solution will be always this. For cos ax, it will be x over 2a sin ax. For sine it will be different cos, and for cos it will be sine. Okay. Yeah. So that you can find out easily by putting the value of x. I mean, if it is sine ax over d square plus a square, then it will be. So you have to mainly find out using whether it is sine square by a square. It will be x over 2a cos ax, or if it is cos ax over d square plus a square, it will be x over 2a sin ax. Okay, you remember this. Then what will happen? That in this case, I left this case, right? So what will happen? So if f of minus of d square minus of a square is equal to 0, then you will have d square plus a square as a factor. So f of d you can write as d square plus a square times f of d, some other f tilde, let's say f tilde, where f tilde of minus a square will be not equal to 0. So you put that value here, and then you keep this d square plus a square as it is, then you can write this. Mainly what I am telling here, in this case it will be d square plus a square times f tilde d of sine ax, let's say cos x also, no problem, that will be 1 over f tilde minus of a square, which is not equal to 0, you know, and then 1 over d square plus a square times sine of ax, and you know also this for how to evaluate this. So you know this, what is the value exactly, and here you know how to evaluate it. It will be x over 2a times cos ax, and here you also know the value 1 over f tilde, some value it will be. So that's how you get the solution. Okay. We will do few examples to like know whether like just relook it and to understand whether you got the point. Okay. Let's say you have to find out the solution, particular integral, or solve this also. In solving this also not difficult, very difficult, you can do very quickly. Okay. So to solve this, you have to find the particular integral and the complementary solution. Particular integral and complementary integral. So mainly for that you have to make this as a homogeneous equation, and from there the particular auxiliary equation will be m square minus 5 plus 6 equal to 0. F minus 1, f minus 6, then will be equal to 0, right? So m square minus 6m, sorry, minus 3 minus 2. Then it makes sense. Yeah, m square minus 2. So m will be 3 out 2. There are 2 roots are there. So the complementary integral will be, complementary solution will be c1 into the power x plus c2 into the power 3x, right? So for the particular integral, what you have to find out, sin 3x over d, which is d minus 3 times d minus 2. So what does that give? So it gives, if you put 3, this will vanish also, but if you can take for d minus 2, so 3 minus 2 times sin 3x over d minus 3. You can write like this. But if you do this, how to handle that again? So it will be 1 what sine 3x over d minus 3. So you make d minus 3, but you don't know the rule for this type of thing. So you know for d square, right? So that's why we make it d plus 3 sine 3x over d plus 3 times d minus 3. What it becomes? So it will be d plus 3 times d plus 3 means sine cos 3x 3 cos 3x plus 3 sine 3x, right, over d square minus 9. Okay, sorry, I made a mistake here. So yeah, let's rewrite it. Okay, what is yp? Mainly finding yp. Okay, let me erase maybe, and then we'll. What the mistake I have done is just putting I am making as a to the power ax, right? It has to be minus of a square in the place of b square, in the place of d square. Okay, so it will be replaced by minus of a square. D square will be replaced by minus of a square. But I was replacing d instead, so that is not true. So that's why I'll make changes here. So how I will write. So instead of first making into as d minus 3 d minus 2, I'll keep it as d square minus 5d plus 6. Now I can put instead of d square minus 3 square, so sine 3x over minus 3 square minus 3 square, remember, so minus 5d plus 6. So that gives sine 3x over minus 9 plus 6 minus 3, right? So minus 3, so minus 5d minus 3, right? Minus 5d minus 3. So now you don't have any d square type of terms. That's why now I make it as minus 5d plus 3. Minus 5d plus 3 sine 3x over minus 5d square minus 3 square. So that above will be minus 15 cos 3x plus 3 sine 3x. For now you got 25d square minus 9 square. Right? Now you know how to handle this. So minus 15 times cos 3x over 25d square minus 9 square. Right? Sorry, not 9 square. 25 square minus 3 square. It will be 9 only. Okay? 9 plus 3 times sine 3x over 25d square minus 9. So you know now instead of d square you can put minus 3 square. So 25 times minus 3 square minus 9. So mainly 26 times 9, right? So 26 times 9 will be 230 if you calculate. Okay. So then the solution will be minus 15 times cos 3x will be cos 3x again over 234, and that is negative of course, and then plus 3 times sine 3x over minus 234. Okay. The solution now you get 1 over 34 times 15 cos 3 particular integral. This is particular integral. Whole solution for the differential equation will be c1 e to the power 2x plus 1 over 34 plus pi with particular integral that implies 15 cos 3x minus 3 sin 3x. Okay, so yeah, you can find out the particular integral for when the right hand side is sine or cos. So all other examples where which involve sine or cos, that you can only sine or cos, not like x times sine 3x or e to the power ax times sine 3x. All those things you cannot do. For those again you have little different way. So yeah, so let's learn some other for some other function. Okay, so if you have like right hand side is x to the power m. So when x to the m, particular integral will be 1 over m to the f dx. So then things become this not just rigorous rule you cannot write here. Let's say you have to find out d cube plus 3d square plus 2d times y is equal to x square. So your integral will be, so will explain the method by taking example. Okay, here in this case x square over particular integral value we are interested in, because the another one will be for homogeneous solution for homogeneous equation is very easy. So that's why I put like this. Then x square over d cube plus 3d square plus 2d. Okay, so that how you can write this, you can write as x square over, you can take 2d common from all the terms, so that will be 3d square, so 3d plus d square. Okay, so now 1 over 2d, let's keep it as it is, then 1 plus 3d plus d square over 2 whole inverse time x square. You can write this, then 1 over 2d, 1 minus 3d plus d square over 2 plus 9 d square by 4. So all other terms will be involved with d cube, and you know when d cube and x square, what it gives 0, because d cube x square is 3 times you are taking derivative of x square. So once you derivative, then it will be 2x, twice you take derivative, that will be 2, and thrice you take, it will be 0. So I don't take, that's why I don't take all other expansion, all other terms, because those are d cube and then it will be 0. Okay, so it will be 1 over 2d x square minus 3 over 2 times x square, d of x square, so it will be of x, which is nothing but 3x. So minus d square by 2 is minus half time d square of x square, so that will be 2 only, right? Plus 9 over 4 times d square of x square, that will be 2 again. So what does that give? 1 over 2d x square minus 3x plus 9 over 2 minus 1 is plus 7 over 2. Right? Again, so this is nothing but 1 over 2 times d inverse times x square minus 3x plus 7 over 2. What is d inverse? If d is ddx, d inverse will be d is ddx. D first will be integration of dx, that of same function. So if you add function f, then it will be f of dx. So that is nothing but 1 over 2 x cube over 3 minus 3x square over 2 plus 7 over 2x. So the solution will be so it will be 1 over 2 times 6 of 2x cubed minus 9x squared plus 21x, that is 1 over 12 times 2x cubed, just making it simple. So that will be simple. It's 21x. That is the solution. I mean, that's the solution. I mean, that is the particular integral which we start. If you want to find the solution for the whole equation, then you have to add the complementary functions. But yeah, more or less, this will be this is how you can solve if the RHS is of type x to the power n. There are like general way, but the way you can solve is by expanding x function by Taylor series x function. Right? So next we'll do when RHS looks like x to the power, sorry, not x to the power, let's say first to the power ax times t, some other function. We'll do it for, we'll learn for this one. So when you have this type of right hand side, the particular integrate, so mainly it will look like for ax p over fd, right? So what we do, we can take this fd out, it is for ax times 1 over fd plus a and times b. It makes life little easier. Then if b is some different function, like let's say sine of ax, then you can put like that. Okay, you can write, you can evaluate. So we'll see how to solve this type of when these type of things are there. Okay, so this is the rule mainly. This is that's all the rule I have said. So now we'll see example where we can use this trick. Yeah. So we found out one. So the differential equation. Let's say we have to find out the particular integral for this type. So d square minus 6d plus 5 times y is equal to x. Let's say we have to find out the solution for this question. Anyway, I will not write the complementary equation or this yc, that all of you know, because this auxiliary equation will be m square minus 6a plus 5 is equal to 0. That implies m minus 3. Sorry, it will be m minus 5 times m minus 1 minus 5 times m minus 1 m square minus 1 m minus 5. So it will be c1 for x plus 5x. Okay. So if you have this, then you need to find yp. What will be? Means the particular integral is x equal x over d minus, sorry, d square minus 6d plus 5. If we make our life easier, you factorize it like 6 minus 5 minus 6, d minus 5 and d minus 1. Now you know the rule, right? It is equal ax times dx, so it is equal ax times a function x over d minus 1 times d minus 5 you have. So what you can write this one as equal x times x, it will act on x, the function will be d plus 1, right, minus 1, d plus 1. Instead of d, you replace d plus 1, right? What did I wrote? Fd instead of fd means d, it was d plus a. So here a is 1, so d plus 1, it is d plus 1 minus 5. That will be equal to x times 1 over d times d minus 4. How do you handle this term? So that will be, it will be x, I said already, so it will be 1 over d, you keep it as it is, and this one will be minus 4 if you take common, 1 minus 4 over, sorry, d over 4, right, times x. So I take 1 over minus 4 as it is, so then 1 over d, it has to be like here. So then 1 minus d over 4, if you expand it, it will act on x, and it will, if you do a Taylor's expansion here, so this will be, we will take up to second order term only, because the other terms will, when it acts on x, it will be 0, right? So d minus 4 plus d square over 4, it will be this kind. So all other terms anyway we are not taking here, because d square, if you take of x, that will be 0, right? From d square onwards it will be 0, so we don't take d square if anyway. So the first term itself we take d plus 4, and that plus other terms which are 0, so we don't consider those terms, and here it will be then yeah, not x, right? So that makes your life little easier. Then 1 over d x plus 1 over 4. Okay, so that implies minus 1 over 4. You have it to the power x. So yeah, let's see if the answer is, yeah, let's say, so 1 over 4, so times it will be x time d will be x square over 2 plus x over because 1 over d means I said the integration. Okay, you can think it as integration because d is integration of dx, integration of the function over the domain over definite integral. So if you had x e to the power 3x, then it would have been, so you have d minus 1 times d minus 5, then it would have been, if you have 3x you take out, then 1 over d plus 3 minus 1, so d plus 2 and d minus 2, right? Minus 6, 8, 16 plus 5, right? D minus 2 plus d plus 2 minus d minus 2 only x. So that gives you 3x times 1 over d square minus 4. But for x to the power m type of function, you do not have any rule. So any particular rule. So as we have, as you know, you have to do like 1 over 1 over minus 4, 1 minus d square over 4. This type of thing you have to do only x. And all of you know that while expanding this one will give you 1 plus d square over 4, and other terms we don't care because those will be 0, even if d square over 4 is also 0, so 1 over minus 4, yeah, minus of 1 over 4 is equal to 3x x times. Say so see, solution should be this. The inner assignment, I think it is given that x square plus half, so that should not be. If it is given the, it's asking x square plus half, then it should be x square. The coefficient should be x square. If the question is it's x is there, then only it will be like this. Okay, if it is x square, then it will be the answer is given is e to the power. So what I am telling, the answer is given e to the power 3x over 4 times x square plus half. So that will be if this is x square times 3x. Okay. Otherwise the solution is this. Whatever I have done. So let's move on to find out if the right hand side is a little more different. So I think that's all up to the rule of for these questions. To solve this higher order differential equation, rules I have already mentioned. Like whatever rule you require, I have already said. So we'll solve few more questions. But yeah, so this is what these are the rules only. So let's say you have to find out the solution for this question. So this is from your assignment. It's equal to d power 2x plus x squared. Okay. So how do that? The particular integral, man, we are interested in particular integral because the other one is easy, you can read it, right? Let's say other one also function. Then what you have to do is m cube plus 2m square plus m is equal to 0. Yeah, no other coefficients are there, right? So then that implies m times m square plus 2m plus 1 is equal to 0. That implies m times m plus 1 is equal to 0. So m will be 0 minus 1 minus 1. So it will be c1 e to the power 0x is constant 1. So plus c2 e to the power minus x plus c3 x e to the power minus x. That is your solution for the homogeneous equation. Right? That's the solution for the homogeneous equation. So that is yc. So how do you find yp then? Yp, because you know the solution, you need to find out the both yc and yp. Yp will be equal to x plus x square as usual. The right hand side over the operator is dq plus 2d square plus t. So this one you can write always as e equal to x over dq plus 2d square plus t plus x square over dq plus 2d square plus t. Right? What does this give? This gives you, if you e to the power, see this rule you know, e to the power ax over ft, you can write as you can write this that as e to the power ax over f of a if f of a is not equal to 0, f is this. So you can put 2 and you can see the root of these equations are 0, minus 1 and minus 1. So 2 cannot be a root. So the you put, if you replace t by 2, then it will be non-zero. So just put it, it will be 2 cube plus 2 times 2 square plus 2, right, plus x square over. So you, for this one we said we don't have any so-called rule. So what we will put is like t plus 1 times 1 plus 2t plus t square. Then you can do it. So that gives you equal to 2x over 16 plus 2 18, right, plus x square over 1 over di as it is 1 over let's say 1 plus 2d plus d square and then negative inverse times x square. Okay, so first term we will keep it as it is. So it is equal to x over 18 plus 1 over d times 1 minus 2d minus d square minus d square plus 2d plus d square whole square, right, 4d square. So it will be 3d square and all other terms will be 0. So all other term will be more than d square, so d cube and all. So we don't care about those terms. So it will be 2x over 18 plus 1 over d times x square minus 4x plus okay 2 means 6, right? That will be equal to 2x over 18 plus x cubed by 3 plus minus 4 2x square plus 6x. That's all. So that will be your solution. That's the solution. So this is how you have to find out. So not very difficult. So let's say you have to find out solution for this type of equation. I mean, you have to find out the particular integral for this type of equation. Okay, let's write this here. D square minus 9 times y is equal to x times sin x. How do you find that? So x times some other function. If you have fd d, then x time e. Then how do you write this one? Do you know this? Okay, so if you don't know also, I will be telling here. So this you can write as x time 1 over fd times d plus you take derivative of this fd, sorry, take negative, and then derivative of f prime d over fd and times this b will be also. So because if you have x square, then this derivative will be more and all those things will be more. So I'll be giving you the general one also. 1 minute, just I'll give you the general also. So the general one I want to give it for fd of x to the power m times this b function from other function. So right now I don't find for this for the rule. Mainly, it will, what I am saying, it will depend on the m power. It will depend on this here. Okay. So for this one, if one, which is just check it for x to the power m times b. Okay. 1 by fd times xb means when you have 1 over fd times xb, so that will be like this. So in this case, that's why. So you have x sine x over d square minus 9. You can write as x time sine x over d square minus 9 uh, minus derivative of this one. So it will be 1 time derivative because x to the power 1 is there, and d square minus 9 times sine x. Okay, so that's how it will be anyway. Okay, so you just take it. So when if it's x square, so it will be twice derivative. So you just check it. So cross check it. So sine x over d square minus 9 plus minus 2 times d of sin x is cos x, right, over d square minus 1. Anyway, so sin x over d square minus 9 will be x times sin x over minus 1 square. So sin x means sine of 1 times x, right? So minus of 1 square minus 9 minus 2 times cos x over minus 1 square minus 9. So that will be, so minus 1 over 10 x sin x minus 2 cos x. That's all. Yeah, so that's what I said. So this is nothing but FD square. So it will be FD square. So D square minus 9 whole square. So D square minus 9 whole square. Okay. So D square minus 9 whole square. This will be whole square. Then things will be different. So it will be x over 10. So but it will be 1 over 5 whole square. So anyway, in the next there is an extra class. So there I will discuss about this also. So for more general one. Okay. But the most probably it will be like f m minus 1 over f d to the power m f m minus 1 t negative of that times the function x, and another will be x time as usual f1 over d times t. So this plus this and minus this one. So these two will be. So now we have reached the last part of the lecture where we'll discuss about the Cauchy-Euler type of equation. Okay? So Cauchy-Euler type of equation, how it looks like, it will be like follows: d x to the power n dy to the power n over d, sorry, dy and y over dx to n plus x to the power n minus 1. Some, it can be a constant c1 which does not depend on any other it does not depend on x, dy to the power n minus 1 over dx to the power n minus 1 plus equals to 1 going like y is equal to 0. So if this type of equation if you see, so then you call it as Cauchy-Euler equation. So in this case we will always take e to the power some z, and if you transform it, it will be a constant coefficient differential equation, and you can solve that, and then you again put back z in the it will be a differential equation in z, and then again you put z back, and z will be ln of x, and then you get the solution. And you get the solution for the differential equation you started. It can be instead of 0, it can be f also. Okay, that's also not a problem. But in all those cases, you have to take x equal to 0. Just blindly don't think about anything. Just take to budget if you are having this type of differential equation. It's not easy to solve if it is not, you are not assuming this x equal to budget and you are not transforming it. Okay, to transform it, you will see it will become a very easy differential equation. I mean, it will be a constant of difference letters, and then you can solve it also. Okay. So let's say you want to find out a different question. Let's say this is the question. So what's the question? Question would be, let's say it is given that solve x cube d cube y over d x cube minus 4 x squared d2y over dx2. So you have always this x square and dx square, like that terms are there. So in 6x dy dx some c0. So here it is, the c0 is 0. No, c0 is 0, but the right hand side we have 7x. So now, like Cauchy, this is a Cauchy-Euler type of equation, right? This is, okay. So if you have this Cauchy-Euler type of differential equation, then what you have this here, so you have to choose that x is equal to e to the power z. So when you take x equal to a z, that implies z is equal to ln of x. So then what you see, this dy dx will be dy dz times dz dx, and from here dz dx will be 1 over x. So then what, using this dy dx will be is equal to dy dz times 1 over x. X is a non-zero, x dy dx will be dy dz. See, you can feel the thing. So I mean, you can see the approach that it is approaching to the constant coefficient. X dy dx will be x dy dx will be dy dz. So this will change to 6 dz dx only. Sorry, dy dz only. So it becomes a little easier. So you will see also d2y dx2. So what will be d2y dx2? d2y dx2 will be ddx of 1 over x time 1 over x time dz dy dz. That implies minus over 1 over x square dy dz plus 1 over x times ddx of dy dz. That gives you minus 1 over x square dy dz plus 1 over x time d dz of dy dz times dz dx. Again, you know dz dx is 1 over x, so it will be minus 1 over x square dy dz plus 1 over x, and this from here you have 1 over x, so it will be 1 over x square, and this will be d2y dz2. That implies x square dy dx, that also, so d2y dx2 becomes also d2y dz2 minus dy dz. So if you just replace inject all these values, so it means x square d2y dx2, x dy dx. Similarly, also you will see x cube d2y dx cube will be uh, yeah. So if you write as this d minus m times m minus 1 times m minus 2, that type of m times m minus 1. So this is m times m minus 1. So it will be m times m minus 1 times m minus 2. Sorry, m minus 1. Yeah, m minus 1 times m. So m square minus m times m minus 2 will give you m cube minus 2m square minus 3m square plus 2m. So what you get is z cube, d cube z dz cube, d cube y dz cube minus 3 times d2y dz square plus 2 times dy dz. So inserting all these values in the differential equation, the given differential equation, so the given differential equation 1 will change to, so we can rewrite we can rewrite 3, we can rewrite 1 as, so see, if you write this x cube, this one, it will be d2 d cube y dz cube minus 3 times d2y dz2 plus 2 dy dz. That's the first one. Okay, then the second one will be minus 4 times d2y dz2 d2y dz2 d2y dz2 minus dy dz. The last term then becomes the x dy dx. We had x dy dx, so 6 times dy dz, 6 times dy dz is equal to, the right hand side term will be 7 times x is e to the power z, right? So you started with x, which is equal to, it was z. Okay, so now if you simplify this, d cube y dz cube minus 3 d2y dz2, and then 4 you have, so it will be 7 d2y dz2, and you have dy dz. So how many terms you have? 2, 6, 8 minus 4 is 4, only 4. Okay. So sorry, plus 4 plus 2 plus 6, so it will be 12 dy dz. So it becomes very easy now. So the transform differential equation becomes very easy, and This equation is nothing but the given equation only, but we just change the variable. So once you get a solution, it will be in terms of z. You just put the value of z, which is equal to ln of x, then the solution you will get. Okay, so now you know how to solve this. So it will be m cube minus 7m square plus 12m is equal to 0, implies this m times m square minus 7m plus 12. So that will be m times m minus 3 times m minus 4. So CF, the complementary function or complementary solution, will be yc is equal to c1 e to the power x plus c2 e to the power 3x plus c3 e to the power 4x, right? And then yp, you have yp, then that will be 7 e to the power z over m times m minus 3 times m minus 4. So that is d times d minus 3 times d minus 4. Okay, so that implies, so this d and the given d are not same. Okay, so if you think d here, d or d is nothing but in terms of ddz, so d is nothing but ddz, right? So now let's take 7 out, then e to the power z. So e to the power z by, you can see, if you put d by, if you replace d by 1, it won't affect anything, because it won't be unvalid, it won't be indefinite. Okay, so that's why 1 times 1 minus 3, you can just put it also. So 1 minus 4, so minus 2 and minus 3, that will be 6. So 7 over 6 times e to the power z, that will be the solution. That will be the solution, I mean that will be the particular integral. So the solution for this differential equation, this one, star, solution for star, for this star, this differential equation will be c1 e to the power. So one thing I made mistake here, it's not z, it is not x, it will be z, all these are z. So okay, e to the power z plus c2 e to the power 3z plus c3 e to the power 4z plus 7 over 6 e to the power z. So solution for star. So solution for the given differential equation will be c1 e to the power z is x, so c1x plus c2 e to the power z is x, so e to the power 3z will be x cube plus c3 x to the power 4 plus 7 over 6 x. So this is your ultimate solution. Okay, so we'll do the last question for this session, like for this tutorial session, and then we'll end the class. So the last question is here. So 2x square d2y dx2 minus 6 1 plus 2x dy dx is equal to 0. So you may feel it's like Cauchy-Euler equation, but it's exactly not. So you have to make some transformation or make some easy trick, use some easy trick to make it Cauchy-Euler equation, then again do like the way we do for Cauchy-Euler equation, the way we solve the Cauchy-Euler equation. So for this one, what we do is we take 1 plus 2x is equal to some other function, let's say uh, t. Okay. So then what will happen? This dy dx you can write as 2 times dy dx will be dt dy dt, and so dy dx will be dy dt times dt dx, right? That implies when what is dt dx, that is 2, so 2 times dy dt. Similarly, dy dx2 will be 4 times d2y dt2, right? So then if you substitute all these things, so it will be the solution, this equation, given differential equation will change to 4 times uh, d2, 4 times t squared times d2y dt2 minus 12 times t times dy dt plus 16y is equal to 0. It's changed to this. So now you put t is equal to e to the power z. Then it will transform to 4 d2y dz2 minus 16 dy dz plus 16y is equal to 0. See how easy it becomes. So it was 1 plus 2x whole square summed by dx2. You make change here, so it transformed to this one, then again it transformed to this one. So now solving this one is very easy, because you know 4m square, that was only the auxiliary equation root you have to find out. 4m square minus 16m plus 16 equal to 0. That implies 4 times m square minus 4m plus 4. That implies 4 times m minus 2 whole square, right? So when you write this, so that becomes mainly c1 e to the power 2x plus c2x e to the power, so not 2x, that's a mistake, always you would do, so 2z and e to the power z times e to the power 2z, right? The solution is this, solution is this, I mean, but you have to write in terms of x, but you know e to the power z is equal to t, so it will be c1 t square plus c2, when you put z, that will be ln of t times z square t square, right? Now still you don't get the solution. The solution will be in terms of x. So t is 1 plus 2x. So c1 1 plus 2x whole square plus c2 1 plus 2x whole square times ln of 1 plus 2x. So that will be the ultimate solution. So the work for you homework, I mean, you think that whether this solution always exists. Does this solution always exist? So to make sure that you have to find whether ln exists, ln of logarithm, natural logarithm of any number valid or not. So homework is, does this solution exist on whole real number? that is your homework. So we'll meet tomorrow. So for today's session is like we'll end today's session. So tomorrow we'll have extra class. Tomorrow extra class, and that is last class for this engineering mathematics 1, and that will be from, if I am correct, 9 a.m. to